Okay, so let's start with example 1. So here is example 1. Your function is f of x equals x squared. Why do we have this domain restriction?
Because it would not be one-to-one.
Yeah.
Correct. It would not be a one-to-one function if it didn't have this restriction. Now the 2 is not vital,
That's not really.
as long as it
Kinda
said,
like saying an interval, essentially.
this is saying an interval. We only want to look at the values between 0 and 2.
Okay.
Which this is a more, this is a smaller restriction than what's necessary. You could have just said x is maybe greater than 0 or less than 0, but this is restricting it even more. So we're just interested in the interval from 0 to 2. So I want you to find, well, first of all, let's say let G be the inverse of f. And then I need you to find the derivative of G at 1. So we can do this without actually having to find the inverse function and then take the derivative and then plug in 1. Of course, here this is a simple function. It would be easy to find the inverse. But all functions are not going to be easy to find inverses of. So we start with a simple example and we'll work up from there. Okay, so our note card tells us that if we're trying to find the derivative of G at 1, our formula would be 1 over the derivative of f at G of 1. So if I'm trying to find G of 1, does that mean I'm plugging 1 into the function f? No. I don't. To find inverse, to find the inverse.
So you find the inverse, plug 1 into that.
So you want to find out when, you're not plugging in 1, you want to find out when does this equal 1. Okay, so make sure you add this. To find G of 1, set f of x equal to 1. Right? If I said find f of 1, wouldn't 1 be your input into function f? But if I'm asking you to find the inverse of function f at 1, then you're trying to find out what input gives you 1 as an output. Remember, inverse functions switch x and y?
Okay.
So doesn't G of 1 mean that you need to find out when your function equals 1? When is 1 the output for the original function? You got that? Okay. All right. So when does this function equal 1?
1.
It could be at positive or negative 1, but I've only got this.
We have an interval.
We only have, we have a domain restriction. So that means we're going to use when x equals 1. So what does G of 1 really equal? 1. So this is the work that I do ahead of time so I don't get tripped up by it when I get ready to put it in here. So now our formula tells us it would be 1 over the derivative of f at what value? At 1, correct. Well, it's easy to take the derivative of f in this case. What is the derivative of f?
2x.
The derivative of f is just 2x. So then that means this formula would turn into 1 over 2x, but in the place of x, we're putting in 1. So then this derivative turns out to be 1/2. Okay? Huh? Oh yeah, you know we're going to get more complicated than that. So let's go with example 2.
Find the third derivative.
Are you looking at my notes, Bennett?
Yeah.
Yeah?
I just pulled them up.
So here's our original function. Again, we're going with the same directions. G is going to be your inverse function. Our domain restriction does not have to be explicitly defined, but isn't it implied? Don't you know that this function already has a domain restriction so that we get real outputs, not...
Oh, yeah.
Yeah, because remember, you can't take square root of a negative number. So this domain restriction is actually implied. So I want you to find the derivative of g at a, and I'm telling you a equals 2. Not quiet all day. Yes, sir. Yes, you may. So to find the derivative of g at 2, don't I need to find, first of all, what is g of 2?
Yep, yes.
So g of 2 means, what does that tell me to do? Set f of x equal to 2, correct. So if we set this function equal to 2, you just solve that. So do you find that g of 2 equals 6?
Yeah.
G of 2 equals 6. What does that mean f of 6 equals? 2, correct. So that might help solidify your understanding that f of 6 is going to equal 2. Therefore, the inverse at 2 is 6. You're just switching those x and y values. Okay, so our little formula from our note card tells us we're going to need to put 1 over the derivative of f at g of 2, which means 1 over the derivative of f at 6, correct. Now all I've got to do is take the derivative of f.
1/2 x minus 2 to the negative 1.
Yes, 1/2 x minus 2 to the negative 1/2.
And you just plug in 6, right?
Yes, sir, then we're going to plug in 6. So I'm going to go ahead and rewrite it like this, 1 over 2 square root of x minus 2, so that it's easier to input the value 6 into it. Question, Bennett.
Since it's to the negative 1/2, would that, and you're gonna put it on the bottom anyways, would that make you put it on the top?
No, that negative is what makes me put it on the bottom anyways.
Wait, what? But if the formula like already
Well, like
calls
with the
for
one
it.
above it,
Oh,
you put the 2x on the bottom.
yeah, I'm going to get this. Yes, sir. I'm going to put this answer that I get in the bottom of that fraction. See how back up here, Bennett? I just found, did 2 times 1. I'm putting that right there. So, yeah, we're putting a fraction into a fraction, yes. So this fraction will go in the denominator of that fraction. It might be easier just to go ahead and plug in 6 right here and find out what f prime of 6 is. What is the derivative of f at 6 if you input 6 right there? 1/4. So then that means over here, this will be 1 over 1/4, which is 4.
Okay.
You see that? So we did put that fraction into the denominator of the fraction from our note card, from our formula. Okay, you good? You need a minute?
Wait, so if you didn't like solve it from that point, and
Then you would've-
how would that look?
That would look, if you didn't go and find out that it was 1/4, then it would have looked like this. 1 over 2 square root of x minus 2. And then you're putting the 6 in here.
Okay.
So 1 over 2 square root of 4, which would have been 1 over 4, which would still be 4. So it doesn't matter when you decide to
Okay.
input your value. We're ready?
And I mean, at that point, you could flip it and multiply by a root, and then you just get 4 on top. of that.
Either way,
Okay.
yes, sir. Yep, either way. Can we move on to example 3?
Okay.
Okay. All right, so if we look at example 3, here's your function. Okay, so I'm giving you the domain restriction that x is greater than 1. I'm telling you your a value is 2. And I'm telling you that g is the inverse of f. And so I want you to find the derivative of the inverse at 2. So for me, the easiest way to do this is to go ahead and write down what that formula tells me so that I don't forget that it has to go in the denominator. So I'll write down the formula from our note card. 1 over the derivative of f at g of 2. And then this is where I stop and I go figure out what is this value of g of 2. So I write down my formula, then I've got 2 calculations to make. So I need to find g of 2. And then I also need to find the derivative of f. So I've got 2 calculations to perform before I can finish using this formula. So to find g of 2, I take my original function f and do what with it?
Set it equal to 2.
So you're going to set f of x equal to 2. How would you solve that? Multiply by, okay. So we'll go ahead and use distributive property. So doesn't that give us this information that g of 2 equals 3/2? Just to review, what is f of 3/2? 2. So just to review that inverse property where you're switching x and y. So this is one of the numbers we're going to need to use. G of 2 is 3/2. The other thing you have to be able to do is take the derivative of f. So there's 2 things we got to do, 2 calculations we have to perform. So find your inverse value first, and then we'll find f of x. How would you rewrite this original function so that you could take the derivative easily?
We give it an exponent.
Yeah.
Write it with an exponent, good. So it's x minus 1 to the negative 1. Thank you. So we take that derivative. Is that what you get when you take the derivative? Okay, so now input your value into it. So if I input that 3/2 into this, -4, beautiful. So then wouldn't this turn into 1 over -4? So when you have low battery, does that mean you can't see anything anymore? Why can't I see anything?